Well, thank you, Remy, and everyone for inviting me to be on a great panel, and thank you for inviting me in to talk a little bit as a Web2 native trying to understand Web3 a little bit better as it is. So as I said before, my name is Kurt Rohloff. I'm CTO co-founder of Duality, and I unabashedly have my favorite open source project, which is OpenFHE, openfhe.org. Thank you, Remy. So just a little bit overall about Duality Technologies. We are kind of a standard VC-backed software technology software, it's a startup. We sell software. So what we do, we sell software to enable secure data collaboration. And we work a lot with governments. We work a lot with large enterprise overall. And you know, for better or worse, and very much for the better for us, we are very happy about our engagement as an investment from Intel Capital, which is, like I said, you know, no small reason why we've kind of seen the light with some of the insights of what's going on with Intel's TEE strategy. And I'm a big fan of it, and we're offering it in some of our products too. But our objective overall is to use privacy technologies writ large to enable secure collaboration, both AI, analytics, and more broadly as it is too. Fundamentally, we are open source. We are all about open source. We are all about using standard technologies. We're all about community engagements. We are only using open protocols, and we are not using any proprietary cryptography or other privacy technologies. We are only using open source, and so basically if you go to openfhe.org, my favorite project, you can basically see the exact same source code that we're selling in our product as it is too. And we think it's fundamentally great that even some of our competitors are using it, not the least of which because it proves out that, hey, there's actually something there. And not the least of which also is that, you know, we love getting into competitive situations with folks using our tech as it is too. And we are also very, very supportive of open standards. And we do try to support, we do try to engage, you know, standards efforts, whether it's with the big nationals like NIST, or it's international efforts like IETF, or the more niche focused consortia like as homomorphicencryption.org. I don't know if I really need to do this, but fully homomorphic encryption, the basic example of it is that you have overall a client that basically can send a public key to a data source. Data source can encrypt that data, send the encrypted data to a host, you know, churn, do some computation without having any decryption keys, nothing fancy like that, send an encrypted result to the client, and then the result can be decrypted and then used elsewhere. And as I was saying on the panel, this thing is very malleable. You can do a lot of things with this. You can have threshold, which is basically you can have decryption only if multiple key owners agree. You can have multiple data sources, multiple hosts, and so forth. And we take advantage of this overall. In the core of this, like I said, is our OpenFHE library. For those of you that are familiar with the technology, oops, pardon me. Familiar with the technology, there's a number of different kinds of protocols that exist inside the genre that is fully homomorphic encryption. CKKS, which is generally used for machine learning, it has real number capabilities. FHE and TFHE, which enables Boolean arithmetic, and BGV, BFE, which is more of integer-based private information retrieval, private center intersection type capabilities. And we basically use all of these for applications for genomic data processing, building regression models, secure query operations, image processing, you know, mathematical operations like PDQs and so forth, PDEs, excuse me. And we do try to, like I said, we want a community. Although we are the kind of the core maintainers of the library, organizations such as Intel, Samsung, AWS, and otherwise, all have been contributing code to the library too. And we have a very healthy group of community members with a discourse group, openfhe.discourse.group. Please feel free to check it out. Our team is very active. We do try to basically be very responsive with folks asking questions to use it. kind of the nature of this, our core team, as I outlined before, myself included, we're all former defense contractors. And basically, when you're writing software for governments, it means you're integrating with a lot of existing legacy systems. And when you integrate with existing legacy systems, it drives a lot of engineering trade-offs around interoperability, the ability to kind of easy integration of new software and things like that. And this is basically one of the main design principles that we've been pushing overall is ease of integration as it is. And also very important for us is we want to have a true open source license. And so we use only the 2-clause BSD, which, if you're familiar with it, is very similar to the Apache license, the MIT license, and so forth. And we did that on particular that we wanted the broader commercial community, startup community, to feeling as comfortable as possible using the library without any kind of concerns about IP or anything or copyright or anything else like that. So please see this as a very, very well-intentioned article of kind of good faith for building community kind of as it is. And we've had a pile of support. DARPA, IARPA, ARPA-H, NIH, Sloan Foundation, and other various funding agencies have been supporting us and our academic partners like Notre Dame and UCSD and MIT and a few others to contribute to the library. So we're very, very happy with the license, with the library overall. Also part of that is that we have a very active standards activity on homomorphicencryption.org. And we basically every 6, 7, 9, 12 months try to get together in a different part of the world and try to have basically work on standards. And standards for us means a few different things. The protocols are all set, they've gone through peer review, but a lot of the standards efforts with FHE is driven more by how do you set the parameters to kind of set security of the technology overall. How do you basically design hardware-software interfaces to make it very easy for hardware vendors to basically plug into the various libraries? And it's not just us. It is a broad set of open source providers that have been in this space. Remy, we were very happy to have you at the last one in Salt Lake City back in October. The next one's coming up in about a little less than a month in Istanbul, Turkey, for those of you that are going to be in that part of the world in a few weeks. But there's been a few other efforts. ISO has a draft standard for homomorphic encryption, which we're very happy about. There's been a NIST call that's going out. They've been very active in the space, in addition to a set of privacy guidelines overall that we've been pushing out. Probably the biggest innovation that we've had over the past year, and this gets a little bit to what I alluded to on the panel before, is we had this advance of what we're calling batched functional bootstrapping. Basically what this is that there are, as I said, different kinds of FHE protocols. One of the ones that's been more widely used in the Web3 space overall is a protocol called TFHE. FHE and the Taurus overall. It's been around for a while. And TFHE has had this ability of doing what's something called functional bootstrapping, where basically if you want to basically run a deep computation, you need to run a computation that basically manages noise so you can still keep a computation going deeply. I'm sorry, it's a little bit of hand waving, but you can kind of trust me with it. And you can run these bootstrapping operations in TFHE previously by also not just running the bootstrapping, but also computation while you're doing the bootstrapping. So it's it's been more effective overall. The problem with TFHE is that it does not allow a very natural compute model. It's things that look like a lot of Boolean logic and Boolean arithmetic and things like that. What we figured out recently in the community is how to basically provide this functional bootstrapping capability, which allows computations with bootstrapping with this CKKS protocol. So it's more native computation that allows native floating point computations. And if you want to start running higher level workloads, like arbitrary function evaluations, like a ReLU, one of the core bottlenecks in evaluating a convolutional neural net, we're basically improving by an order of magnitude and faster than one could do with FHE and TFHE. Basically, 3 orders of magnitude performance improvement overall, which is a nice thing. compared to scalar methods, and then BFE is, like I said, order of, not quite an order of magnitude also. And so we're seeing that basically the broader adoption of these technologies in furtherance of secure AI, semantic search, fine-tuning of large AI models, and unlocking a wide set of things overall as we go. And so here's the main reference for it. My long-term research partner, Yuri Polyakov, published it along with Andrea and my former postdoc, Andre Kim, also. And so we're doing these things, and kind of one of the core examples, and this is something that Remy and I were talking about over lunch, is basically what we call fine-tuning or transfer learning. And one thing that we've seen often in at least the government space is that the government really, really, really wants to leverage existing open and commercial technologies. Commercial Gen AI, commercial LLMs, things coming from Facebook and Meta. The trouble is that these commercial models are trained in the general, and they often need to be, retrained, fine-tuned, improved for use of kind of more enterprise applications, such as medical image processing, looking at, classifying of machine parts, and so forth. And so there's this process in AI, basically what's called fine-tuning, where hand-waving, if you have a kind of like a 7-layer CNN, 7-layer convolutional neural net, if you could basically go and retrain or tune the bottom layer, the final layer of the CNN. And it's called a fine-tuning set of capabilities. And so what we've been doing is we've been figuring out how to basically do fine-tuning on things like neural nets and other kinds of more complex AI-type capabilities, and enabling this fine-tuning on encrypted data. So you could take a commercial model, you could take encrypted data that you're really sensitive about, and do the fine-tuning in something like an open commercial cloud and things like that, and unlocking overall with very high levels of security, and on much lower cost because you're running in a commercial environment also. Excuse me. I guess that's the last slide. Well, like I said, I'm happy to be here. Like I said, do please look us up. Open FHE is, like I said, the core open source library with the core FHE capabilities. And at Duality, we're taking this into the commercial market to apply it into real world application. So thank you very much for your time.